Now what we're going to do is go ahead and use our geometric definition in order to graph a couple parabolas. Since we're starting out in general form, we want to get it in vertex form first, so that we can get the location of the vertex, the focus, and the directrix, and also identify our focal width. So we're going to have to complete the square. Since we're completing the square on the y values, we want to move everything that's not a y term to the other side of the equation. So we'll have y squared plus 2y. We'll put in our boxes because we're completing the square. We're adding 6x and subtracting 13 to 0 so that our non-y terms are on one side and the y terms are on the other. We'll use our completing the square formula, b over 2 squared. Since b is 2, what goes in the box is 1. This allows us to factor the left side of the equation, and the right side simplifies to 6x minus 12. If we want to get it in standard form, it's really easy to finish this off by just factoring out the 6 on this left side, on the right side here. So we have y plus 1 squared equals 6x minus 2. Or we can get it in vertex form by isolating the x. Either way works. We can take y minus 1 squared, or sorry, y plus 1 squared, and we can add 12 to both sides of the equation, and then divide by 6, so that we're left with x equals 1/6 y plus 1 squared plus 2. And so now we have our equation. We can identify our vertex. When we compare it to our formula, 1 over 4p, y minus k squared plus h, our h is equal to 2, k is equal to negative 1, and then we can deal with p in a moment, but our vertex is going to be at 2, negative 1. Now in order to get p, our leading coefficient is 1/6, and that has to be equal to 1/4 compared to our formula, where p is located in our denominator. So if we cross multiply and solve for p, we get 6 over 4, which reduces to 3/2. You can also write this as 1.5 if it's easier for you. So since p is 1.5, and because it's y squared, we have a horizontal axis, we know that our focus is going to be 1.5 units right of our vertex. So we started our vertex at 2, negative 1, and then we move 1.5 units to the right for our focus. And that's at the point 3.5, negative 1. We also know that our directrix is going to be 1.5 units left. And so 1.5 units left, we're going to have that vertical line at x equals 0.5. So we have our vertex, our focus, and our directrix. Last thing we're going to do is use our focal width in order to finish our graph. Well, remember the focal width is the denominator of our leading coefficient. So our focal width is 6, which means that a line that's running through the focus has to be 6 units long to intercept our parabola. Well, if the whole line has to be 6 units long, that means we need to go 3 units up and 3 units down in order for the full line to be 6 units across. And since we have that focal width, we can now fill in our parabola. Let's do it again with b. We want to complete the square. This time we're completing the square on x. So we'll leave our x terms on one side, and we're going to move our non-x terms to the other side. Using our formula, completing the square by adding 1, we can factor the left-hand side. On the right side we simplify, and then we isolate our y term. So if we go ahead, let's move y to the other side. and compare it to our formula. We see that our vertex is located at -1, 2. And then here, for our p-value, we see that our leading coefficient of 1 has to be equal to 1 over 4p. Well, if we multiply both sides by p in order to isolate p, we see that p has to be 1/4. And so our focus and our directrix are not going to be very far away from our vertex. Since we have a vertical axis parabola and p is positive, we know that the graph is going to open up. So we start at our vertex at -1, 2. And our focus is only going to be 0.25 units above our vertex, and the directrix will be 0.25 units below at y equals 1.75. So we have our focus at -1, 2.25, and our directrix at y equals 1.75. Now, since the denominator of our leading coefficient is our focal width, and our denominator is just 1, we know our focal width is 1. That means that from the focus, the width of our parabola is only going to be half a unit to the left and to the right in order to get that full 1 unit. So our graph is much narrower because we have that smaller focal width. Last one here. We want to start by completing the square. Since we have x squared, we want to move all of the non-x terms to the other side of the equation. So we'll have 6y minus 10. And here we have a leading coefficient of 3, so we do need to factor that out first. And remember that on the right side, we're going to multiply this box by 3. So we put 1 to complete the square. 3x minus 1 squared equals 6x minus 7. Get it into vertex form, we'll add 7 to the left side and divide everything by 6. So we'll get 1/2 x minus 1 squared plus 7/6 equals y. So our vertex is going to be located at 1, 7/6. Our focus, in order to find our p-value, 1/2 has to equal the 1 over 4p. So we multiply both sides by, or cross multiply, 4p equals 2. So p equals 1/2. So our focus will be 1/2 unit above the vertex. We know this because it's an x squared equation, which makes it a vertical axis parabola. And then because p is positive, we're going up. And so 1/2 unit up, we want to add that to the 7/6. Our focus is going to be at 1, 5/3. And then our directrix is going to go in the opposite direction. So if we subtract that 1/2 from our 7/6, we get our directrix at y equals 2/3. And so we can go ahead and graph these. So our directrix is at about y equals 2/3. Our vertex is located just above 1, 1. And then our focus will be just below 1, 2. And then we look at our focal width, and we have a focal width of 2 because our denominator is 2. And so that means 1 unit to the left and 1 unit to the right to finish our parabola.